Now, for this particular problem here, they want us to find any relative extrema, max, min, or no change. List each extremum along the x value in which it occurs. Um, Identify intervals over which the function is increasing and over which it is decreasing, and sketch the graph of the function. What I would probably do is sketch the graph on my calculator first to give me a heads up as to what I expect it to look like, and then just confirm my results through the algebra here. So the first thing to do, they give us the function. So we find the first derivative, set the first derivative equal to 0, and find our critical points. Okay, so I find my first derivative here, and I set it equal to 0. Find where it's equal to 0, but doesn't exist, and that's a potential critical point there. So I set it equal to 0 here. So that's our critical point. And the ordered pair would be negative 5 over 2 and 29 over 4. That's our potential min-max there. So we got to figure out what's it doing. So we check what's going on either side of the critical point, looking at the slope, if it's increasing or decreasing. So we analyze the behavior of f prime between the critical points on a number line. So this is our critical point here, x coordinate. So we're going to look at one x coordinate would be our test point would be at negative 3, and the other one would be at 0. So these are our test points. So we end up testing. We end up testing the behavior of the slope here. So I put a negative 3 in here into my slope, and I see that it's greater than 0, so I have a positive slope on this end. And I put a 0 in here, and I have a negative slope, less than 0, so it's negative on this end. So it's going up, and then it's coming down. That means I have a maximum at this critical point here. So I have a maximum at this ordered pair. And we can see that from the graph on your calculator. And there's the graph there. And you can see the intervals, the intervals here.